everyone, this is John Faulk here with JagSuccess, and today we're going to be covering piecewise functions and graphing piecewise functions as seen as in Precalculus. Let's go over the notation that you'll see. Usually you'll see f of x equal to a set, which let's say in one case we have 2x plus 3 when x is less than 0, and 2x squared minus 2 when x is greater than or equal to 0. So these are two functions. You're going to get different results based on where you are on the x-axis. So if we're below 0, we're going to be using this function right here. And if we're at 0 or greater than 0, we'll be using this function. So let's see what this would look like on a graph. Okay. Let's give ourselves some points here. And these are all going to be increments of 1. So this would be -1 to -5, 2, 3, 4, 5, -1, 4, 5, 2, 3, 4, 5. What I like to do, which may help you out, is I like to take what's right here, this 0, and plug it into here for x and see what I get. So 2 times 0 plus 3 gives us 3. And if we plug 0 into here, 2 times 0 squared is 0 minus 2, which gives us -2. And notice this is strictly less than. So this is going to be an open dot. And this has an equal sign. So this will be a closed dot. So if we go to the point 0, x equals 0, and we go up to 3, this is going to be an open dot. And if we go down to the point -2, this is going to be a closed dot. Okay? So we're going to look at everything where x is less than 0. And less than 0, we have this function 2x plus 3. So if you notice, our slope is going to be 2. So when our slope is 2, because this is just a line, so when our slope is 2, or 2 over 1, this is rise over run. So we can either go to the right 2 and up 1, or we can do the complete opposite. We can go to the left 2 and down 1. And since we're going to the left, because x is less than 0, then we'll be using the to the left 2 and down 1. So we'll start at this 3 right here. So we'll be going, I'm sorry, this is rise over run, not run over rise. So we could go up 2 and to the right 1, or down 2 and to the left 1. So we'll be going down 2 and to the left 1. Sorry about that. So we'll be going from 3 down 2 and to the left 1. Okay. And then we can go down 2 and to the left 1. Okay. And now we have enough for our line. Let's do that again. So that will be our line. Now, for everything at 0 and greater than, we're going to be seeing this parabola right here. So you can either one, find out the vertex and the x-intercepts and begin to graph this. The easier way to do more complicated functions like parabolas is to just plug in points greater than 0 in this case. So if we plug in 1 into here, we get 2 times 1 squared. So that's 1 times 2, which is 2, minus 2 is 0. So at 1, we get 0. If we plug in 2, we get 2 times 2 squared, which is 2 squared is 4, times 2 is 8, minus 2 is 6. So let's see, at 2, we'll add one more here, and we get 6. So what we get, if we connect all of these, we get this parabola. And that's a pretty simple one. So remember, this tells you everything about what you're doing. If you're going to the left, or if you're going to the right, it also tells you if you need an open dot or a closed dot, depending on if it's equal to or not equal to. So let's look at a little bit more complicated example. Okay. Let's say we have f of x is equal to the set of functions, and we're going to have 2 when x is less than or equal to negative 2. We're going to have the function x plus 3, and this is when x is greater than negative 2 but less than or equal to 1. And let's have the parabola x squared minus 2 when x is greater than 1. Okay, so this one's a little bit more complicated. So let's go over to the side here. Now it doesn't matter what x you put in here below negative 2, your y is always going to be 2. So you just have 2. So if we test the 2 points here, when we have negative 2 in for x, we get negative 2 plus 3, which is 1. And then our other endpoint, so this is going to be a open dot since there's no equal to sign. And this is going to be a closed dot. Okay, so if we look at 1 plus 3 is 4. And since this has an equal to sign, we're going to have a closed dot. So one more to look at. If we have 1, so 1 squared is 1, minus 2 is negative 1. And since we don't have an equal to sign, this will be an open dot. So if we draw a graph, let's put some points on it. Okay. So let's go to each of our points. At negative 2, when x equals negative 2, this one gives us 2. So negative 2, 2. And it's a closed dot. Okay. So now we'll be looking at negative 2 again. And when we're at negative 2 for this function, we get 1. So negative 2, 1. And we have an open dot. Alright. And then when we're at x equals 1, in here we got 4. So 1, 4. And when that's a closed dot. And then we have, for here, at x equals 1. We have an open dot at negative 1. So right here. So let's go back to our first function. So y equals 2 if it's below or equal to negative 2. So everything below x equals negative 2 is going to be y equals 2. Okay. Now we see between x equals negative 2 and x equals 1, this is simply just a line. So actually we can just connect these two as a line. Okay. And this is a parabola for everything over x equals 1. So let's just plug something else in, like x equals 2. So 2 squared is 4, minus 2 is 2. So at 2, we get 2. Let's plug something in, say 3. 3 squared is 9. 9 minus 2 is 7. So let's add some 6, 7 up here. So 3, 7. We know this is a parabola, so it's going to give us this curvature here.